Welcome to the Customer Lightning Talk, and the topic for this session is how AWS helps Variant employ a driver-first data-driven strategy. So, I am Sandeep Madhumanchi. I am currently working as the VP of Engineering for Variant. With me is my friend TG Matthews. He is currently serving as the Business Intelligence Manager at Variant. Before we get into the topic and go into our slides, I want to provide a quick context on who Variant is. Variant is a trucking company serving its key customers who are its drivers, and we at Variant consider our drivers as our heroes. So some of the talking points for today are what is the role of a truck driver in order to contribute for a healthy supply chain. We're going to know a little bit more about Variant. We also want to discuss about the problem we are trying to solve and the roadmap for the solution, the steps we took, and the key decisions we made. And finally, TG will come up and he will explain the positive impact the solution has on our business and our operations. So, if you just going to make what role do truck drivers play in a healthy global supply chain? So, if you think about it, when you go onto a highway, trucks are an extremely common sight. But trucking industry in general is a kind of an $800 billion industry. Trucking is essentially from the start of the first industrial revolution. The transportation of goods and the operations is very critical for our livelihood. Truck drivers play a very critical, important role as part of these operations, and they're essentially the backbone of American economy. If you think about a very simple scenario, we as a customer, we want to purchase some items. These items are being manufactured, and these items are then kind of packaged, and these items are then delivered to us through a truck. It brings us a smile on our face. But the reality of the situation is, if you consider the global COVID pandemic, though it created a state of adversity, it also created a kind of a point of inflection. Well, if you look at the truck drivers, they were very essential in order to deliver critical supplies like food or medical supplies to the store, which essentially kind of found their way back to the cabinets at home. So if you look at them, the truck drivers went from essential the truck drivers kind of like their status got elevated to frontline heroes. So they essentially are our heroes. So what are the truck drivers telling us, right? So if you look at every story has a hero, and every hero has certain challenges that they have to face with. This is no different with the truck drivers or the trucking industry in general. If you think about it, the trucking industry is facing a big driver shortage problem. And this problem has been from 2018, even before the pandemic. The pandemic just kind of made it worse. The real question is, why is there a driver shortage problem, or why there is an increase in the aging truck driver population? The answer to that is, trucking is an extremely hard job. It is physically taxing, and it is mentally stressful. And on top of it, truck drivers, they kind of leave their family members, and they probably are away from their family members for a long period of time. So if you think about it, the trucking job is not something that is it's interesting for a young person to go and pick up, right? Now, how does this affect us, right? Like you and me, how does it affect us? Like in any industry, let's say in the IT industry, if you have a shortage of a particular skill, you're probably going to put in a lot more money in order to get the kind of the right talent, right? But essentially the company's operation cost fundamentally increases. Now, if you take trucking industry as an example as well, if there's a driver shortage, you're probably putting in a lot more money in retaining those drivers, which means that the trucking operation cost increases as well. Now, you and me can go to Amazon.com, buy a product, it says free shipping, but it's technically not free, because you are paying for the price. The price of the shipping is included in the product. So if your shipping cost increases from the trucking companies, the cost of the product also increases. So that's kind of like, it goes like a full circle, and it comes and affects the end customer and also impacts the global supply chain. right? So, and that's why I kind of feel that the trucking is one of the hardest job, and retaining drivers is one of the toughest problem. Now, what are truck drivers telling us? Now, the truck drivers, as I said, their life is kind of really difficult, but they also are dealing with difficult challenges. Their load assignments could be volatile. When I say volatile, these assignments could be changing very frequently, or it could be abruptly changing. So they're asking us, hey, when you assign a load to us, make sure it doesn't keep changing. So there has to be a pattern of predictability, right? And that pattern of predictability, if it is not there, at least ensure the change is not like abrupt and it is managed efficiently. Now, the next thing is about route optimization. Route optimization is very essential for the for this whole scenario. There are many factors which come into play, right? You are driving. Essentially, there's something called hours of service, where a truck driver has a certain he cannot kind of like work for more than a certain number of hours. So you plan the route accordingly based upon the hours of service available. Now you hit traffic. Now you are stuck in the traffic for 2 hours. You have to now re-optimize the route and present a new route to the driver. So route optimization is very critical, and getting the data real time is also very important. The other important thing that truck drivers tell us is home time is necessary. We all need time off, so does the truck drivers. They also need time off. They also want to be with their families, and they also do not want to miss any critical event of their loved ones. Most importantly, they are alone on the road and they need operational support. So there's always a trucking operations team, but they need to be presented with data of changing factors as early as possible so that they can provide the best support over there. So who are we? So we are Variant. Variant is a digital trucking company. It is founded by US Xpress to revolutionize the trucking industry. It has a unique take on asset-based career model, with there's a core emphasis on execution and planning. We use at Variant, we use the AI and we use AI and machine learning algorithms in order to kind of get the predictability. So our main goals that we kind of include are, we want to provide consistent miles for the drivers so that the drivers get a consistent pay. We want to honor their own home times so that they can go and meet their loved ones when they want to and not miss like any of the critical events. We also want to reduce their wait times between delivery windows so that they are just not sitting right there for the next delivery to happen or next delivery to start. Most importantly, the core goal of Variant is to kind of treat their drivers with respect. Now, in order to kind of get to where we want to build a data-driven solution. The aspect that we need to understand is that we get data from various sources, right? We get data from IoT sensors, we get data from call centers, we get data, we have the traffic data, weather data, you get data from the engines, like the health of the engines. So there are several factors to consider. Each of these factors, each of the data that we collect, it helps us to kind of make those decisions. For example, we can get the data of an engine and we can figure out whether the truck needs to go and shop. And if the truck needs to go and shop, we can assess that data and we can create a ticket automatically. And that ticket helps the operators to basically know, okay, there is something wrong with the engine, the truck needs to go to shop, here is a ticket, and then they'll call the operators and they will let the operators to reroute, or they will let the engine will kind of reroute the operators, right? Now, why is this kind of a difficult problem, right? Now, if you look at a traveling salesman's problem, the premise of the traveling salesman's problem is, if you have a bunch of cities and if you know the distance between the cities, the goal is to find the shortest distance from the origin, cover all the cities and come back to the origin. That's what the premise of a traveling salesman problem is. You add a myriad of factors to it. You add factors like weather, you add factors like traffic conditions, you add factors like the regulations like hours of service, or the home time, or the availability of trailers, availability of tractors and stuff like that. The problem becomes $1 billion problem. And that's what we are trying to solve at Variant by collecting all this information and optimizing it. Now, what are the key steps we took in order to collect all this data? First thing we said, let's not build a data dump, build a data lake. There's a huge difference between a data dump and a data lake. Yes, both of them use S3 as a persistent storage, but the problem is the first pass we took, we used to collect all this data. We used to write individual programs for each of the sources and just throw it in. And there we had CSV files, we had JSON files, we had all kinds of files, right? And the reason it becomes data dump is I have access, you have access, everybody has access. It's kind of very difficult to control the access unless you go to IAM and then keep putting on each bucket and each policy, which kind of becomes like a little bit clumsy, right? So the first thing, as he said, no data dump, let's build a data lake, and then we chose the AWS native services. Now, why did we choose AWS native services? So if you look at the screen, right, AWS provides a lot of services across messaging, analytics, storage, orchestration, compute, and security. When I look at that, those icons, what comes to my mind are Lego blocks, right? So if you think about Lego blocks, they are different colors, and they probably could be different shapes, different sizes. And I don't think these services are any different. They are Lego blocks by themselves. Each service has its own set of properties. It can do certain things. But when you connect more than one Lego block, then it basically has a different, it can create a new pattern. So what we started looking at it is, let's treat it as Lego blocks. Let's build patterns. So instead of treating each source, let's find out what is the common patterns. Let's take a simple example, right? End of the day, the data will come from different sources. It will come and land up in S3. When it lands up in S3, first we will apply glue in order to get the metadata out of it. Then we will drop it into Athena. We can drop it into Redshift if we are using Redshift, but in this case we didn't. In our case, from Athena you can directly visualize. This portion of S3, glue, Athena, and QuickSight, that's almost fixed. That's not going to change. What's going to change is at the top end of it, right? Now, let's say if you are trying to get it from an external SQL server, okay? So you're going to take the event bridge cron, one of the Lego block. You're going to put a step function. You're going to put a lambda. Then you're going to go and extract the data from SQL server, throw it into S3, glue, Athena, and QuickSight, right? That's what if you're getting from external SQL server. Now, let's take a different scenario. Let's say you're just getting it from one of your own sources like RDS, right? In that case, you take RDS, you get DMS, Data Migration Service, where again you throw into S3, glue, Athena, QuickSight. Kind of the story keeps repeating, right? Now, for example, we get IoT data by a vendor, and that data goes into a RabbitMQ, right? So we can use the RabbitMQ. So what we can have a lambda, or we can have a program in EKS, kind of listening to it, get the data, you can put it into SNS, and then you can send it to SQS for operational, or you can send it the same way back to S3, glue, Athena, and QuickSight. So the patterns keep repeating. So we don't look at different sources, we look at patterns. So end of the day, we ended up with like about 7 patterns. So we have call center data coming through topics. We have the IoT sensor data coming in queues. We have some of the vendors where they ask us to interact through API integrations, but all of the data it kind of falls broadly into these 7 categories, and that's what we call as pipeline patterns, right? So end of the day, what we wanted our solution to be is we wanted our solution to be serverless, extensible, persistent, centrally governed, performant, and flexible. What I mean by this is that when we got the data, we converted the data into Parquet format. We wanted a consistent storage. We use Parquet because it's columnar store. So I don't have to scan the entire table. I don't have to put indexes. I can only find the value I want to find. The query times will be kind of less, and it will be faster, and it has a higher compression rate. And then we put it we use the lake formation so that I can centrally govern who has access to what. So if I am ingesting data, but I don't want, like for example, TG to kind of use it in his dashboard yet, I can kind of make sure that TG does not have access to the data because I'm still working on it. Once I'm done, I can put it into a silver layer, and I can then have TG to either model it or he can either analyze it, right? So now I'm going to pass over. So one more point before I pass over to TG. The best part, if I'll go back to the previous slide, the best part of these Lego blocks is you can also integrate with mega blocks. That means you can go and integrate with any of the other AWS partner services. For example, not a great fan of CloudWatch, but we use Epsilon for our tracing, right? But we can use PagerDuty for our instant management. So you get that flexibility with AWS. You can use these services, and then you can also integrate with the partner services and create the patterns that you want to create. So I'm going to pass it on to TG, who's going to tell us how the solution kind of created a positive impact to both business and operations.
Okay, thank you, Sandeep. So my name is TG Matthew, and I'm the BI engineering manager at Variant. So first off, what we have heard so far is nothing new, right? We've all seen a lot of companies implement data lake, but the key thing that you want to consider is we started off with 4 trucks in October of 2019. We've grown to 1,800 trucks by now. So the scale at which we have grown is exponential, and the journey has been hard. And it's only going to get harder with every truck that gets added to our network, right? But we fundamentally believe that what we have displayed here, what we've shared, is going to be foundational for our success down the road, right? So where are we now? So where are we now? The 4 things that Sandeep mentioned earlier, those were the main things we want to hit. So first off, we have more predictable load assignments for our drivers, which is what they long for, so that they get predictable pay, right? Each week they want to know that their paycheck is going to be steady so that they can plan around those budgeted items. So that's the reason we are focusing on predictable load assignments. To do that, we have to consider a lot of feedback from the optimizer that we are on. Next, we have to consider route optimization. For that, we are not just using the regular GPS to get the truck from point A to point B as the fastest route, but we also consider the hours of service, which is basically how many hours the driver has been driving before the driver can actually get home, right? And then we also consider a range of other variations, not just traffic data and the telematics from the truck, but it also considers the fuel efficiency on the truck, right? Do we make a stop and fill, or do we run on empty, or whatever? So route optimization is not just regular GPS, but it's more than that. Next, we talked about the voice of the driver, where getting them home on time for their family events is really important. In an industry where we have a driver attrition of about 130%, our lofty goal is to get it to 40%. And to achieve that, we have to start measuring. One of my mentors used to say, you can't improve what you cannot measure, right? So for that purpose, we've started measuring home time compliance. We just started the journey, we've not mastered it. There's a lot of variability to it. There's a lot of human element involved into it, so we have to learn what the preferences are, how do we bake it into our algorithms, and so on and so forth. But we've started the journey. So finally, if all of this technology does not address the human factor, which is our drivers building a relationship with us as the people interfacing with them, what's the point? It's just technology just becomes a transaction, right? So we talked about the ops folks who's there 24/7 to guide the drivers through their journey from home back to home. For that, we have to free up their time so that they can focus on the driver problem and not worry about, hey, where's this data going to come from? What do I do with this? And call IT support and spend their time on the IT support phone call, right? So considering all of this, these are the business impacts that we've worked through. So next, we talked about all the business impact for our drivers, but what about the teams that are implementing it, right? I want to walk you through a couple of the key things that Sandeep mentioned earlier. One is the standard pipeline. We talked about the Lego patterns. We broadly brought it down to 7, right? So in that, the standardized pipeline profile That basically allows us to know what we are signing up for, which means it's a predictable output, right? So if I say, hey, data ops team, I need this done, I know that what used to take 3 or 4 days before, because they implemented the pattern, it can be done in 2 hours, right? So they just have to plan it into their backlog. And the next thing is, because we know what to expect and what pattern they're going to use for a particular solution, we know that we can start planning around those things and start placing them in a roadmap, and we can start being predictable. And that's something that management always wants. Hey, when are you going to get this thing? When do I get my stuff, right? Then finally, not finally, there's 2 more. So we talked about serverless being one of the serverless architecture that we've implemented. That has basically allowed us to be devoid of any constraints on compute and storage. And that has allowed us to not be held back by provisioning challenges at that point. So what does all of these lead us to? It leads us to improved prototyping. That is, we can fail fast and operate in an agile environment, and therefore deliver faster. If it's wrong, it's wrong. We'll at least be able to pivot sooner, right? So overall, what does this mean? Everybody, like I said before, everybody builds a data lake, right? But the reason that makes it most meaningful for us as we're building this out, it affects the livelihood of our 18-wheeler superheroes that we've set out to serve. So thank you. So if you have any questions, Sandeep can take it up.
I would like to thank my data engineering manager, Kwong Lin. He and me started this journey when we joined Variant. Conceptually, provided a lot of inputs, but he was the person who executed it. A big shout out to his team. But again, before we conclude, any questions? Sure.
So you talked about the heroes, which were the truck drivers.
Yeah.
After you did this entire solutioning, what was the Variant's customers impacted with the supply chain data solution?
Yeah.
What was your customers' feedback on your validation?
So as I previously mentioned, our main customers are our truck drivers. And yes, we are serving for some of the retailers and stuff, right? So think about it. I could have 3,000 trucks, but if I don't retain my drivers, I will not have enough seated trucks to kind of like, meet my deliverables. So it is kind of like a ripple effect, right? So if you retain your drivers, there's a high chance that you can go and meet your customers. But if you don't retain your drivers, then there's a ripple effect that you cannot do it, right? So for us, once we achieve our goal of retaining drivers, everything else will more or less fall in place.
And second question.
Yeah.
With the pandemic, did it complicate your journey because your actual heroes were were on the road, and
Yeah.
the pandemic was in full swing?
Yeah.
So did it complicate your task?
And I think every year, I think when the weather hits really bad in February time, that's probably the worst period, right? Because when they are on the road, I mean, suddenly you have these, traffic kind of shut down, or there are extreme weather conditions. Then they are means even sometimes even to park the big truck on the road, on the side of the road, it's not an easy job. Yes, they all get impacted. The operations team will normally works with them for across day and night to kind of provide whatever support they could. And a lot of the times, working in the trucking industry and working with the truck drivers is all about showing empathy. Basically, their lives is a lot more different than our lives, right? So we are sitting in this room, and we can go out and buy a can of Coke or pick up a can of Coke. It's not that easy for them, basically. So, yeah.
I saw that you get into a lot of analytics. Like, what is your take on machine learning, or are you using machine learning? If so, where are you in the journey, and what are the tool stacks are you using? Because I'm from machine learning background. So
Yeah.
I'm interested in that.
Yeah, I'll take a stab at it. Yes, we do have data scientists who are working on machine learning models. One of the model we're working on is driver iteration, right? So now in terms of tools and technologies that we use, there is a part of the there's a group of people who like SageMaker. There's a group of people who use external like data robot because it kind of provides ready-made APIs where you provide an input and provide an output, right? So we're kind of like divided there. But there is like, at least I have the desire to build what we call it as MLOps, like a MLOps team, which kind of focuses on, which lets the data scientists do their job of building these great models, but we want to productionize it. So we want to support multiple environments like SageMaker or Data Robot or maybe something else, right? So we are still in that initial part of the journey. Right now, we kind of serve the data scientists on a case-by-case basis, but at some point, we'll probably mature there. Yeah. Yeah.
You mentioned drivers home time.
Yeah.
They never calculate that. How successful have you been in creating that algorithm for
You want to take that? Yeah.
Yeah. So, like I said, the question is. And we've promised it, and that's why we're starting to measure it. We were thinking we were good at it, but the driver feedback on our Facebook page and the conversations we've had at different places are like, you know what, you're not measuring up to it, right? And the fuel prices and the weather that Sandeep mentioned in February timeframe, and the lull in the market is not helping us because we are having lesser and lesser options to play with to get them home on time. So it kind of keeps us on the back foot. So if we measure, we can start categorizing them into where we need to focus, like what's the bulk of the home time problems, and then we can start fixing. Because if we don't know that, we won't be able to be successful. So we've started that journey now.